Hello everyone. Today we will discuss about the electrochemistry. Electrochemistry is that branch of chemistry which deals with the study of production of electricity from energy released during spontaneous chemical reaction and use the electrical energy to bring about non-spontaneous chemical transformation. Importance of electrochemistry. The importance of electrochemistry is the student always thinking why we should learn the electrochemistry or why we should study the electrochemistry. So this is the importance by which we can understand how this electrochemistry is used day by day. First, that is production of metal like sodium, magnesium, calcium, aluminium. It is used in electroplating. It is used in purification of metal. It is used in batteries that you are used in your inverter day to day, in cell, and used in various instruments. To understand the electrochemistry, first we have to understand the electrolytes. What are electrolytes? Substance which allow the passage of electricity through their fused state or aqueous solution or undergo chemical decomposition are called electrolyte. For example, aqueous solution of acid, base and salt. If we learn it in a simple way, any substance which dissociate into its ions is known as electrolyte. For example, NaCl. NaCl is get break into Na plus Cl minus. So it is an electrolyte. Similarly, if I take an example of HCl, it get dissociate into H plus Cl minus. So it is an electrolyte. Now we will proceed. That is, electrolytes are of two types. First, that is strong electrolyte. Strong. You know what is the meaning of strong? So strong electrolyte. The electrolytes that completely dissociate. What is the meaning of completely? Means complete ionization. Okay, what does that mean? Suppose we take an example of HCl. HCl, it get break into H plus and Cl minus completely. Okay, this arrow indicate there is a complete ionization. Okay, what is weak electrolyte? Weak means partial ionization, means substance which is undergo partial ionization. Let's take an example of acetic acid. CH3COOH will gives you CH3COO minus plus H plus. So here acetic acid is break into acetate ion and H plus ion. Here the sign is reversible. So you can easily understand when these arrows are present, then there is a partial ionization. Is a partial ionization. If this arrow is present, then complete ionization is present. So if complete ionization, the electrolyte is strong. If partial ionization, then electrolyte is weak. So here we take example. This is weak electrolyte. This is a strong electrolyte. I already discussed here. Here this is the sign for partial ionization. When partial ionization takes place, then ionization constant is between 1 to 2. Value of ionization, if 2 or 3, then it is a strong electrolyte. Okay. Now we will proceed forward to the next topic, that is electrochemical cell and electrolytic cell. If you want to understand electrochemistry in a proper way, then we should remember one thing. The whole chapter is divided into the two cells. First is electrochemical cell and another is electrolytic cell. If you read like this, first electrochemical cell or electrolytic cell and then another cell, then you will learn this chapter very easily. Okay. So here first we will discuss what is the difference between the electrochemical cell and electrolytic cell. Electrochemical cell. What is electrochemical cell? Device which convert chemical energy into the electrical energy. Whereas electrolytic cell, device which is used to carry out a non-spontaneous chemical reaction by electrical energy. You know what is the meaning of non-spontaneous process? Process which do not takes place on its own. Okay. So in electrochemical cell, movement of electron from anode to cathode in external circuit. Whereas in electrolytic cell, electron enter from cathode and leaves by anode. In electrochemical cell, the cell reaction is spontaneous, whereas in electrolytic cell reaction is non-spontaneous. You know what is the meaning of spontaneous? The process which takes place on its own. Okay. So these are the difference between the electrochemical cell and electrolytic cell. Here, first in this chapter we will discuss the electrolytic cell. Okay. Electrolytic cell. So what is to understand this electrolytic cell? Before understand this electrolytic cell, first we understand the topic, that is electrolysis. Electrolysis. The meaning of electro means charge and lysis means to break, means any substance which can break into charge. Okay, that is electrolyte. And process is electrolysis. Okay, so what is electrolysis? It is a process of decomposition of an electrolyte. When electric current is passed through either its aqueous solution or in molten state. Let's take an example of table salt. When table salt is present in the bottle, can it break into the Na plus and Cl minus? No. When moisture or water is there, then this NaCl is get break into Na plus plus Cl minus. Okay. Now we'll move forward. So here is a typical example of an electrolytic cell. In electrolytic cell, this red rod, we consider it as a anode and we connect it with the positive terminal. Okay. So anode is positive. It is positive in electrolytic cell. Okay. This black rod is cathode. We connect it with the negative terminal. So charge is negative. Okay. You know at anode oxidation is takes place. What is the meaning of oxidation? That is loss of electron. And at cathode reduction is takes place. So what is the meaning of reduction? That is gain of electron. When a electrolyte is present in this solution, then it is get dissociated into its respective ion, in which an ion means negatively charged species will goes to the anode, whereas cation positively charged species is goes to cathode. Okay, so at anode oxidation is takes place, that is why X is get converted into the X minus is get converted to X plus electron. So here is a loss of electron is takes place, whereas at cathode M plus plus electron will gives you M. Here gain of electron is takes place. So whenever we want to discuss electrolytic cell, you remember one thing. First, anode is positive, cathode is negative. At anode, oxidation is takes place, means loss of electron. At cathode, reduction is takes place, it means gain of electron. Okay, negative ion will move towards the anode and positive ion will move towards the cathode. Okay, so The important thing to understand the electrolysis is discharge potential. What is discharge potential? The minimum potential that must be applied across the electrode. This is the potential. This is the battery which provides the potential to this electrolytic cell. So now minimum potential that must be applied across the electrode to bring about the electrolysis and subsequent discharge of the ion on the electrode. So if I say simply, the potential which is required for the electrolysis is known as discharge potential. Okay. So now we will move to the next part. How to predict the product of electrolysis. This is very important topic. Here I take only two examples, that is example of molten NaCl and example of aqueous NaCl. First, I take the example of electrolysis of molten NaCl. Here is the setup. So here is the voltage resource. The left electrode is anode. Anode is connected to the positive terminal, that is why it is carry positive charge. This right hand side electrode is cathode, which carry negative charge. At anode, oxidation takes place, whereas cathode, reduction takes place. In reduction, gain of electron takes place, whereas at anode, oxidation takes place, means loss of electron takes place. When we use molten NaCl, what is the meaning of molten here? That is liquid NaCl. When liquid NaCl is present and we pass electricity through this electrolytic cell, then NaCl is get break into the Na plus Cl minus. As you know that negative charge ion will move towards the anode and positive charge ion will move towards the cathode. Okay, so this is the anode reaction. At anode reaction, twice of Cl minus will get converted in the Cl2 and 2 electron is lost. So which process takes place here? Oxidation. Okay, whereas at cathode, twice of Na plus 2 electron will gives you twice of sodium, which is present in liquid state. Here gain of electron takes place, that is why process of reduction takes place. So what is the byproduct of electrolysis of molten NaCl? The byproduct are Cl2 and sodium. Cl2 is present at anode, whereas sodium is present at the cathode. Okay. Now we proceed to the next part, that is electrolysis of aqueous NaCl. Here aqueous means dissolve in water, means H2O plus NaCl in this equation. Okay, so electrolysis of concentrated sodium chloride solution. When two electrodes are connected with a battery B, this positive terminal is anode and negative terminal is cathode. At anode, oxidation will takes place, means loss of electrons, whereas at cathode, reduction takes place, means gain of electrons. Here H2O is get break into H plus OH minus, whereas NaCl is get break into the Na plus plus Cl minus in this solution, because the solution is contain H2O as well as NaCl. Okay, here are two H plus ion. Here are H plus ion and Na plus ion. So there are two cations and there are two anions. Okay, so out of this Na plus and H plus will goes first here, and it is get reduced into the hydrogen gas, whereas out of OH minus and Cl minus will goes first at anode, and it is get oxidized and get converted into the Cl2 plus twice of electron. Okay, so in left hand side, that is at anode, at cathode, sodium ion is present. At anode, hydroxide ion is present. Okay, so the net reaction will be H2 twice plus twice of NaCl will gives you H2 plus Cl2 plus twice of NaOH, in which H2 is present at cathode, where Cl2 is evolved at anode. Okay, so the byproduct of aqueous NaCl is H2, Cl2 and NaOH. H2 at cathode and Cl2 at anode. So today we will stop our video here. Okay, in next video we will discuss rest topic. Thank you.